Counted as vectors, yes. We kind of done that from the quiz that we did. A couple of quick definitions that we need to make, and then we jump right into the problem. Okay? So a vector, we said earlier, I'm going to make it here. A vector has both what and what? So if you're talking about like a number line, right? And you could like represent where something was based on the number line. We do kind of a simple vectors, but because we have direction, we can't just use a number line. So we have to know how vectors work. So if we draw a picture of a vector, okay, the length of the arrow dictates the magnitude, or represents the magnitude. And the way the arrow is pointing represents the direction. Okay? So that we're all talking about the same thing, just a couple of about the vector of the arrow itself. This part up here is called the head. And the vector in this part down here is called the tail. Okay? And sometimes we have vectors and they're just one plain old vector, but a lot of times we want to do something with the vectors. Like, I don't know, add them. Okay? If we need to add vectors, we're going to do it in a very specific way. And in order to add vectors, we line them up head to tail. And I'm going to add some more things under that in just a moment, but I want to try out a problem first. The first three problems that I have here are ones that I wrote, okay? They start out very simple. We like to start out simple so that we're all on the same page of understanding what's happening. But I want you to go through the process every time so that when they get more complicated in about 5 minutes, you know what you're doing, okay? Because I'm not going to do these simple ones forever, just like I did one. So here we go. Example 1. Kermit walks 15 meters east, 10 meters west, and then 7 meters east. What is his total displacement? Now, you may be able to do that and tell me, Kim, I know it. That's great. Good for you. I'm so proud. Once you draw a picture of his path. Okay? Use vectors. And probably naturally, go ahead. Use those vectors to figure out his total displacement. And once you think you've found that total displacement, then check with your table mate and see if they agree with you. And if you're missing a table mate, you don't have to be sad and alone. We're here to support you, I promise.
Pull out of the driveway. Yes.
What'd you get? 12 meters east. Yeah. I haven't done it yet, so let's walk. Can you Okay. Sorry, I don't want to take you literally. Okay. Uh-huh. About 2/3? Exactly 2/3. Why is it 2/3? So something like this? Okay. Mhm. Like here? Okay. Okay. Sweet. And your answer
Result.
resultant part of the day, right? To go. Of the first, or the tail of the first, to the head of the left. From the tail of the first, left. So these really connect to it's going to go from here to there. Okay? And that's so the resultant vector is 12 meters east. Doable?
Yeah.
Okay. Everything else? Everything else? Make sure. All right. So I'm going to write that down so we know. So it's going to be head to tail, and the resultant will be drawn from the head, excuse me, from the tail of the first. To the head of the left. Okay. Okay, David? Yeah.
So when you add vectors
Yes.
with different directions,
Yes.
not like along the same plane.
Not in one dimension.
But the triangle method thing.
Yeah.
So is the direction of the resultant vector in relation to the first vector, or which that I?
We're going to get there. Actually, example 2.
Okay.
We'll get there. Is that okay?
To draw triangles.
Let's do some triangles. For example, I think this will get you where you need to go. Here, walk 4 meters north, 12 meters south. What is the total displacement? Yeah, that was actually physically drawn on your paper. I'm going to draw an axis to have something to kind of go on. And then I'm going to go ahead and draw my vectors. 4 meters north. Now, you don't have to get a ruler out or a meter stick. Okay? But you do want your vectors to be kind of about the right relative sizes. So I'm going to call this one, I'm going to call this one A. That will have, not only talking about like for real. And then I'm going to have this one B. And so first that's 6 meters. And then from there, where do I go? Down, I go south, right? So I'm going to go. And how far am I going to go south? Well, the axis is going to go further down. Good. Something like this. Okay. Then the next thing I need to do is to draw the Resultant vector, yes.
Let's do it. Draw the resultant vector. It's going to start from the tail of the first and go to the head of the last.
Okay. I'm going to call it R. You can call it whatever you want as long as it's clear what you're doing. Now, this resultant vector, you figure out the magnitude direction of it. What's the point? It's true. Now, I don't have a triangle, but I have a trapezoid. Help me. Talk more. Okay?
So I'm going to cut the x-axis with the line here. And if I do so, can you tell me the length of that line? Okay. And then the other side of my triangle is going to be her.
And how long is that side?
8.
8. And how do you know it's 8? There's nothing in the problem that says 8. 12 minus 4. Okay. And it is a nice right triangle. And if you know your 3, 4, 5 right triangles, you can tell me right away that R is 10. If you don't know your 3, 4, 5 right triangles, that's okay too. You're just going to do 6 squared, which is 36. 8 squared, which is 64. And 34 is 100. Divided by 10. So the resultant vector is 10 units. Am I done?
No.
Why not? I don't have a direction. It's got no direction, right? I need a direction. Now, what do I can describe it, right? What did you say? Southeast. Look at this. We're looking at it like a map, right? North, east, south, west. And from the place that we started, we need to turn southeast. I agree. Now, how many different dots are 10 meters away from the starting spot southeast? A whole lot. Now, if I told you to go 10 meters southeast, do you know where to go?
Nope.
No.
You could go anywhere along the circle in this quadrant. So that's going to be angle. Okay? Now, you have done awesome. Distracted. Sure everybody's there. Okay. In order to find the angle, I'm always going to put I'm going to go down a little bit just so that we can get ourselves familiar with this stuff, this sign. If you are taking notes right now, I'd like you to draw a right triangle. Okay? And then pick an angle that's not the 90 degree angle and then just to memorize something, focus on the right triangles as the is true. And until we talk about things in terms of just call these right? I want to just differentiate this leg and this one is across the table. Okay? The opposite side of the triangle. I'm going to call that the opposite side. This one here is right next to it, so I'm going to call it the adjacent side. way to keep track of what that is word SoCal. Okay? Now, department to find this recommend learning you all of those definitions. They are. So the S in SO stands for sign. It's spelled S-I-N-E, but it's so S-I-N. It's just a ratio between two sides of the cycle. And you can figure out from this is the first one up and that is opposite. And the second one, H was on the bottom. Hypotenuse. Okay? Good? Knowing that, then we can probably extrapolate what the others are. Let's go through them. The next one, Ka. The C stands for cosine. That one's even longer. So we're going to call it COS. But again, it's not cos, it's cosine. Okay? Cosine, if we look at the SOHCAHTOA mnemonic device, tells us that what comes on top? Adjacent. And what's on the bottom? It's true. And what do we do last one? Two things. Oops, I kind of. There it is. TOA. T stands for tangent. Again, the amazing we're just going to do the first three letters. And we know what it is. Opposite and adjacent. You alright? Again, if this is brand new to you, don't freak out when the other people around you have been doing this for you. Okay? You're exactly what they're doing, it's okay. You have to learn it once and it's very more fun. Through it. Okay? All of this information is on your purple equation sheet. On your equation sheet, if you want to double check, you can find it on there. Okay? It's all there. It's a medical problem. Okay. Alright, so I'm going to take this information and figure out this angle. Now, you might argue that you know all pretty well. But usually, this is not going to be defined. We know these ones for sure, so let's do these ones. Okay? This is the what to this angle. This is the what to this angle. Adjacent. When you say a function that uses opposite, what will the function is going to be tangent, right? So just one step at a time. So the tangent of theta is equal to the opposite divided by adjacent. Now, generally you will need calculators for this. So if you do not have a calculator, pull one out, and I know that I think mine is across the room. I'm going to go back. What's that? You can use your phones. I would prefer that in the future when I have calculators, you not so that you're used to a calculator. The other thing I really want to make sure you know is that if you are using a calculator, okay, well, any calculator. Okay, so if you're in high math and you're doing, you need or to turn it into degree. I don't know how to do that on a straightforward calculator. I don't know. But you can talk to to Becca. Talk to Becca, you know how, okay? In order, over here. In order to solve this table, we need to undo table. You want to undo adding, what do you do? If you want to undo dividing, what do you do? Because they're the inverse functions. If you want to undo table, what do you do? Inverse tension. Inverse tension.
Enthusiasm. This is what I'm saying. A is going to be equal to 10 to the -1. It's a button. So if you see the sine, cosine, and tangent buttons on your calculator, generally if you do second and then that thing, that'll get you the tan inverse. 8/6. Okay? Go ahead and try that. Yes, ma'am. Because I want to know theta. I don't want to know the tangent of theta. I want to know theta itself. Does that make sense? Okay. I'll go look at the picture and come back. If you want to put anything, the first time you on that, that's fine. It may or may not work. I think they do though. Want the really big one? I don't know what better to think. What's up? Engine? Something that doesn't make sense.
Okay.
This one. Are you sure? Really? Look. Oh, Dad. So, you go second, and then you break, and then go down, or you go second, and then
I do that all the time.
I will tell you, ladies and gentlemen, if you need a calculator and you just need it for this stuff, this is like the best calculator you can get for cheap. Right here, it's just isn't even that much? 15? I think I got mine for like 12. Okay, they're not expensive. You can go to Target or Walmart or wherever calculators are sold, right?
It's free shipping, so. Alright, what did you get for theta?
Point.
.43.
Do you want us to do decimal places with the degrees?
I would say just round to the nearest degree.
Okay.
53. No, that's what I'm telling you. Those guys are weird. Okay.
So you go to the home menu.
At 52 degrees. 52 degrees what?
Southeast.
Southeast. How many different places are 52 degrees southeast at 10 meters?
1.
2. There are 2 places that are 52 degrees southeast. There's one like the one I'm drawn, and there's one over here, 52 degrees this way. You see what I'm saying? Actually, so we have to be a little bit more specific. We're almost there. The last little bit, one of the things we're going to do it. I want you to take your pencil. Pencil.
move it, but it's pointing along the back. Okay? Here I was pointing which way? East. I had to turn which way? South. South. I have to turn 52 degrees south from east. Okay? So 52 degrees south of east. Okay? Of east. Give me 4. As long as, okay? Are you doing all right? Can we try another one? Yes, question?
On my thing, I'm getting,
You get a decimal,
yeah,
which means that it's in radians, and I know that you can change it, and this is why I said I'm not gonna help you with those because I wasted an entire block one day trying to, and I don't know. So you can talk to Becca, this minute, and she can help you out, okay, once I get started on something, yeah.
so I looked at 10 years ago.
Where did, yeah, because that was a while ago, right? Where did that 10 come from? It's the length of our hypotenuse. So it's a squared plus b squared square root. Does that make sense? Okay, yeah.
With these axes, we have like the cardinal direction.
Yes.
So if you don't have those, does it matter which direction, which vector you're basing your direction of the resultants on?
No, as long as.
Okay. Yeah, I was kind of freaked out.
So I would say like. All right, let's try another one. Do you guys know the method students who? Beaker's the one with the really tall head and the orange hair goes, me. That was the guy in the last one. One time you do is his sidekick, or I guess, actually Beaker. Exactly. All right. What I do is going west. Now you can tell by the way it goes. 2 kilometers west, 3.1 kilometers south, and then west again, 4.2 kilometers. The question asks for you to find his total displacement. So you're going to start by doing what? Drawing a picture, okay? Establish your resultant, and then break it down. I want you guys to work on this. I'm going to work on it up here too, but I would like for you to try. If you get stuck, then take a look up here. Does that sound okay? Okay, there we go. And please feel free to talk to your table mates. Okay? Please talk to your table mates as you go. It's okay, I'm just moving it down. Sure, you don't memorize? Come on. So sometimes on this problem, people want to try and break it up into 2 little triangles. I would strongly encourage or discourage that. Strongly encourage against that. I would recommend making one big triangle like this or one big triangle like this. It doesn't matter where you go. Okay? But make one big triangle.
Again, it's really okay to talk to each other. Talk it out. Physics is much more productive and much more successful when you work together.
You see, like, how these two.
They do, but don't do it. Does that make sense? Yeah. Does everybody have the measurements written down? Can I scroll down just a little bit, please? Is that okay?
Do you always want us to use functions?
But when you're take the vector that you,
Okay.
but in this case, because this is exactly 11, the that is less accurate than this, so use them. That makes sense.
Oh, I think
Yeah.
Like for the same
Can I say something? Ladies and gentlemen, I want to interrupt you for just a moment. If you're still working, fantastic, keep working. If you are ready to
look at, they are on 91 numbers 2 and 4. And our let's take a look at page.
no.
Does that make sense? So,
I gave you an answer a moment ago, so waste of time. Let's finish with this problem. Open your textbook to page 1. Work on the first 4. 2 and 4. Okay? You have a question in there. But other than that, on problems, not yet. Okay, so far?
Mindset. Drop. Died. No, the cast. Those are fresh. I had excess in the bag.
I mean,
Like,
Okay.
right.
are you trying to remember that?
Yeah. Not you.
Yeah, 45.
Yes.
Brenda.
Okay. Let me go for
Kevin. Here.
9.
Brenda.
Two problems from the book. As you're going through the homework, it should be a little bit easier now to do, okay? Next time we work together, we'll do some more practice with this stuff, and we'll go through some more questions if you have them. Does that sound okay? Please make sure that you borrow a calculator from my table. All of the textbooks are away. I mean, have a fantastic Wednesday, and I'll see you Friday.